Please look at today. Can you hear? Can you hear me? Okay, we will start now. So please look at today because today we want to teach you Ansys Workbench instead of the AIM. When you look at Ansys Educational, please go to that website to download the software called Ansys Student. Please look at that version because I have already asked the master course or final year project student, you can download these three. One is Ansys Student and the other one is AIM and also the live. When you look at the Ansys Student, we have the license here. What include? Mechanical. We haven't got in our laboratory, but here we have. Today we will cover some safety for Ansys Fluent. And also how can we create a mesh for the final elements here. Before that, we will using the Ansys Workbench because Workbench we can make some static analysis. We call it structural analysis here. So you can see the Workbench we have got many analysis like static structure or shape optimization, or you can make some and other like the thermal analysis here. So when you download these three, we have different software inside. So what's included? That one we have got vibration in the AIM. You can download both in your computers because you just get the zip file and then unzip it. So AIM we will teach you next week, next Saturday. We will teach some of the, because the user interface is quite a simple one. So we will teach the AIM too, not just the Ansys Workbench. Inside the Workbench, we have got vibration, thermal, fluids, and also multiphysics and automation. But I will not teach all because most of them we have got the common ways. You need to create some names, and then before that you need to make some mesh before you run. So it is not that difficult. When you learn one of the analysis, you can know the other one. Because data analysis, we can apply the fixed point and force into your object. But thermal analysis, you need to apply the thermodynamics like heat flux, radiation, convection, or the heat temperature inside. We have the thermal conditions inside. So although we will not cover all of them, but if you want to use it, we have got some common way that you can make it. But please look at the geometry because in your student edition, you can't using Power Solid to make it. Power Solid is your SolidWorks. When you export, I think Inventor we using export, but SolidWorks we can file save as another file format. Because save as in Inventor we can't save another format, but SolidWorks we can. Inventor we need to using export the CAD format here. Don't using the Power Solid one, using the STEP because when you using Ansys we can't import Power Solid. Your version you can't. Commercial license we can import the Power Solid step file or IGS files. It is two different software. In our laboratory we can using Power Solid to make it. What feedback? Oh, WhatsApp. Doesn't matter. STP is that file. When you using some simulation, we need to save three files. One is Power Solid, STEP, or IGS. We just got three files that you can import the geometry from SolidWorks, AutoCAD, or Autodesk Inventor, CATIA, because those software we have got another file formats, not just you can create the Inventor part or SolidWorks part file. You can file save as another file format. So the step file is very important because I have already tried PowerSolid. PowerSolid, we can't import the geometry. So we need to using another way to make it. So you can see the geometry input, you just got 2 in student edition. But in our laboratory, in CF 304 or EF 301, we can import the PowerSolid, not just these 2, STEP or IGES. We have PowerSolid inside. So when you look at another Ansys software, we will not cover that one because that one is create the geometry by your own. We call it Ansys SpaceCAM based geometry modeling. We will start from 2D sketch to build up the 3D model. So if you haven't got SolidWorks Inventor, you can download that one. We call it Ansys Discovery Live Student. So when you look at those 3, we have got some common way. But today we just want to cover a simple one, is Ansys Student, because that one we have got the workbench. That means inside we have got many plugins that you can make it. I will open the startup dialog box because I have already installed the Ansys Student for teaching this semester. When you look at my desktop, we have got the workbench 2019 release 3. Just double click it. You will see some of the analysis system on your left hand side. So today, before the break, I just want to cover the static structure. We can simulate the stress, strain, and also displacement using that static structure here. So we need to drag the static structure into the project scheme because we call it project schematic here. We have got the flow chart. That means we need to create geometry and then make the model and then make the setup is the boundary condition like the fixed point or the force. And then solution is you need to using analysis tool to calculate it, and then you can show the results for the post-processing results here. So when you look at that one, you just drag your analysis system into the project schematic here in Ansys Workbench. I don't think I teach in summer before because previously we haven't got any Ansys Mechanical in our laboratory. But when we download the student edition, we can have the full version toolbox. Not just got the static structure, we have got the topology optimization, and also we have fluent flow, and also you can see we have many different analysis system inside. So today we just want to cover a simple one first. For some of the course, I will not using that one. I will using AIM because AIM is quite simple software. You do not need to using Workbench like that way. It's just import geometry, set up some of the boundary condition, and then create a mesh and then run like the SolidWorks or Autodesk Inventor. You just got a few steps here. So please look at today because today, when you learn some SolidWorks or Autodesk Inventor before, you have already got the skills, draw the geometry first. But in Ansys or MSc Patron, we always don't want to draw the geometry in those two software because SolidWorks and Inventor is quite user-friendly that you can draw anything by your own from the work plane to draw the 2D, and then using 3D features like extrude, revolve, sweep, and loft to create your 3D objects. So we will not using Ansys to make it. Why? Because we always using coordinate system to draw something like AutoCAD. But when you draw it, is draw a point first, and then draw a line, and then using the 3D features to build up. So it is too difficult for the student to draw the geometry in Ansys or MSc Patron. That's why we will using SolidWorks, CATIA, or Autodesk Inventor to draw the geometry, and then using file save as the step file to import it. Please look at today because I have got one of the case is I demonstrate in some of the course before. We call it mobile phone casing. So you can download that one later on for your trial version. So please look at here because the first step, you need to import geometry from any CAD software. We call it computer aimed design software. You just can import the step file only because your version is not commercial version, or in our laboratory we buy the academic one, so we can import the Power Solid. But that one we need to import the step file. So you can just right click and then import geometry. Browse, and then that file is under the semester 2. One of my course is master course, and then here. You do not need to join because Blackboard we have already got the STP file. When you finish the import your geometry into that software, we will got some of the update for the model because error in importing Power Solid file. I have already tried Power Solid because in our lab we can using Power Solid, STEP and IGS file into our system. But your version, the workbench, we can't. So you prompt the error message here for the Power Solid because your version. So that's why for SolidWorks, you need to file save as the STEP file. Or Inventor, you need to using export to the CAD format. We have got STEP file to make it. When you edit it, you need to edit the geometry jump into another windows called Ansys Mechanical because Ansys Mechanical is related to the static structural analysis. So that's why when you edit your model, the 3D model, it will jump into Ansys Mechanical. So please look at here because the text, that means we finished to import the geometry, but the model, you need to edit it. So please wait, because from the workbench to another software, we call it. When you edit your model, you can see we will jump into Ansys Mechanical. Previously in our laboratory, we haven't got it. Also got the problems. Need the license, we can't make it. Quite strange. Right? Oh, because I'm using Power Solid file. Sorry about that. So I need to update another file here because he prompts some errors for the Power Solid file. Suppose it's step STP. That one is when I check the properties is the STP here. So I input the not correct files, so it will prompt something wrong for the editing. So maybe I cross it out for the Ansys Mechanical first because we can't import the geometry. So we will edit again for the Ansys Mechanical. Sorry about that because I have too many files in one folder. So sometimes I click into the wrong files, not Power Solid one, STEP. You can look at that one for the step-by-step, but I want to cross it because it is not that difficult. I have already imported the geometry from Autodesk Inventor or SolidWorks to Ansys Mechanical now. So you can see that one, we call it Ansys Mechanical. And also stand for the static analysis, same as your SolidWorks or Inventor. I have already shown in some of the course before. So please look at here, Ansys Mechanical, we have got the step-by-step on your left-hand side, same as SolidWorks, Autodesk Inventor, we have some step-by-step on your left-hand side. So you need to assign the materials first, and then the materials, we have got the materials properties. So I think in this into your solid bodies. We just got one solid. That means you just got one materials. That one is your mobile phone case. Maybe I can apply ABS or the other plastic parts that you can apply it because one object is one materials only. You can see that one. I have already assigned one of the materials. So you need to create the material assignment by your own and then assign one of the materials here. Shows it from the library or the other things. Search maybe ABS, plastics. You can apply it and then delete some. So we're using the ABS as the materials property here. Why I can't change? Is it I can edit? Engine data. So maybe project materials. But I'm not using the structural steel here. Let's look at here. Is it I have? Also, I don't know why we can't delete the first one because the first one is not ours one. But you need to select the objects to apply it because when you look at that one, you can see the geometry row selection. That means you need to select the object that you want to apply the materials here. Select all of them and then apply. Also no selection. Geometry selection. Okay. Apply it. When you look at the geometry selection, you need to select the whole object and then apply the body because the whole body is just one materials only. So I just apply ABS as one of the materials here. And then you can see my notes. After you setting it, you can set some of the analysis setting like the support and also the loadings. We call it force or pressure. Same as SolidWorks, we have got those features here. So mechanical, you can go to the setting here. Insert the setting. Insert the setting, we can insert the fixed support. And then the fixed support maybe I just rotate it using that face to make it, apply it. One face select is the fixed one. And then I can apply another analysis setting is the force or the pressure. Maybe that one I want to make a pressure to press it onto that face and then apply it. And then the pressure, you can see the unit is PA. You just type maybe 200 PA here. You can make your own assumption for pressure or the force. So analysis setting, you can set some support fixed point, we call it, and then we can make some loadings for the force, pressure or the moment here. So you can see the fixed point is one of the phase, or you can put some vertex, we call it the points of the supporting point. And then the force, you can see the force is Newton, but pressure is in PA. The unit is PA. After you generate all of the analysis setting, you need to generate the mesh. We call it finite elements analysis. So you can go to the mesh and then generate it. It's quite automatically. I don't think you need to using your own setting to make it. But if you want to using your own setting, it doesn't matter. You can go to sizing to make your own mesh size. Maybe that one I want to using 0.1. Why? The thickness of the mobile phone casing is 0.8 mm. So 0.1, that means we have got 8 mesh for the edge. So sometimes I can using that one is in meter. So you need to using exponential to make it, or just make something like that one. It's okay. I just want to make that exponential because some of the software like Ansys always using not mm as one of the unit. They always use a meter. So you need to change from mm to meter first. And then the size, I have already did it. And then update it. Generate again. Size. Let's check the setting first because I changed it. Is it already updated? Oh, because I never select, I forget always the yellow color, you need to select the object for all of them. Maybe you need to using Control key to select all of the face of the object. And then apply it. So you can see you can generate the mesh again. In this case, Ansys Workbench, you can see when you mesh it, mesh is not a solid object, it's for the face. So if your mesh is too small, it will take time to generate the mesh. So after you generate the mesh, you can solve the solution. Same as SolidWorks, we can get some results later on. Maybe too small. Because I'm using the face mesh, so sometimes maybe it takes longer times to generate the mesh. Maybe I stop here and then generate it. not using the mesh. Delete it, and then generate again for the auto mesh. More faster when you're using the default one. And then you can click into the source, the simulation, to run the results. Don't using the mesh is too small because it takes time. It takes longer time to generate the mesh. You can see all of the text you have already finished. That means you can display your results here. Click into the solution part, and then you can see some solution that you can click into it. So when you look at the solution information, we have some information here, and then you can insert, and not insert the insert the stress, and then insert any one of the stress here. So sometimes I just want to display that one. I can evaluate all results. So it is not that difficult for you to understand, because also the same skills when you make it. When you go to the PowerPoint notes, I have already asked you click onto the solution and then see different results, because when you right click, you can show all of the results here, and then you can generate one by one, like the displacement. Displacement, we are not call it displacement in Ansys Mechanical. We call it deformation here. So you can also click into that one and then insert again for deformation total. And then when you want to show it, you can see the displacement is quite small. But why we have got the deforms of your objects? Also the scale problems. So we need to go to the result part. Maybe I'll delete that one first because it's not correct. That one. When you go to see the stress, I think we have one of the scale factor here. You need to click into some of the options, because the results from export to that one. We need to change the scale for actual scale. I have already asked you that one is not the actual scale. Actual scale is here. You can see we have got true scale. Same as SolidWorks, we have true scale. Inventor, we are not call it true scale, it's actual scale. So when you look at true scale, suppose the deform is not like when you select the true scale, all of the data, it will go to true scale. It is not the same as SolidWorks. When you need to edit the definition, you need to edit one by one. But in Ansys, when you change one of the results is true scale, all of the results should be true scale, because I can insert the string. Now, the string is that one. And then you can see the string data is also in one true scale now. I think when you look at the Ansys Mechanical, is quite user-friendly. We just got a few steps here, same as SolidWorks or Autodesk Inventor. So I will demonstrate maybe SolidWorks to you to look at it. Before I demonstrate SolidWorks, maybe I can demonstrate another software called Autodesk Inventor. Because I have already opened the Autodesk Inventor here. I will open the files called STP. When you look at environments, we can have got the stress analysis. Name is not the same, but same theory here. Create studies for static analysis. And then you can assign the materials. Some of the course I have already mentioned, SolidWorks or Autodesk Inventor are the same steps. Assign materials and then constraint. You need to make the fix. Fix, we call it the fixed support. And then you can get OK to make it. Pressure is that one. And then that one is MPa. Maybe I just make it 200 PA here. Okay? At 200 is too small because it represents the MPa is too small. So I need to maybe just using 0.2 MPa here. Select this face and then OK. Contact point, you haven't got contact point because just got one object. We do not need to contact from one to another. So we can create a mesh and also simulate. I think some of the course I have already demonstrated similar step by step. But when you look at Ansys Mechanical, also on your left-hand side, you can apply one by one. And also the scale, we call it actual. Because actual scale, you can see it will have got some deforms here. SolidWorks is also before the break, I just want to show you these three software are the same skills. Simulation, and then new studies. Also, you can select the static analysis. Assign the material first. Plastics, ABS. Fixed geometry, also that face. Pressure is that one. And then that one, you can see it is quite different from Inventor or the other software. You can choose some of another unit. Then create a mesh and run. You can see that one when you edit the definition. Please go to the similar things, we call it deformed shape. So true scale. I think true scale in Ansys Mechanical also we have got the true scale here. So please go to true scale, or we call it actual to make it for the emanation, because that one is the deformed emanation here. But when you look at that one, when you show it, you need to edit the definition one by one. But Ansys and Inventor, you do not, because once you have already made the scale into true scale, it will automatically change. But SolidWorks, you need to add it one by one for true scale. You can see the string is also deformed like that way. But when you edit the definition, you need to go to automatically. You can see SolidWorks is not that good enough because automatic is quite large deformed shape for SolidWorks. So that's why you need to go to true scale to plot stress, displacement, and strain. But some of the software, we are not call it displacement. We call it deformation. Same as Ansys Mechanical, we are not using the terms called displacement. But it doesn't matter. It is most likely the same. Before the break, I just want to show you why we're using Ansys to make some of the things. And then after the break, we will share the information for the CFD because most of the students maybe want to learn CFD instead of CAE. CAE, some of the course we have, ME 42005, ME 548, or ME 42006, we have already got some of the skills like ME 32002, we have CAE. So CAE may be not all of the students want to did it in different software like Workbench or Ansys but final year project, please using Ansys. I think some professors, if you want to get high marks, don't just using SolidWorks to simulate your simulation in your final year project. So you will get high marks for another software because Ansys inside we have got many plugins. Now we take 5 minutes break. Any questions you can ask. If you have got the mic, you can ask some questions.